This is a long question.
Holy.
Obviously, you don't have a final semester exam for the second semester in this class, so you don't have to write it down. But read it through once, and then I'll just kind of use a visual representation so you can see what it really means if this doesn't do it for you.
Carol, you're back.
Yes, I am.
Welcome back.
Thank you. I was at a doctor's appointment for the past, 5 classes.
No, we've all.
We missed you.
Thank you. I'm glad to be back.
Good.
Kind of. What?
We're almost
Pretty
done.
run in the middle for me.
Hey, 2 more lessons.
It's not weird.
Then tomorrow we're
That's
done.
right.
I'm gonna be honest, I've seen you guys doing weirder.
Who wants to go on strike?
All right, here we go. Here we go. So, where this question comes from is, for a while, I worked as a steel bundler in a factory. Long story. It was at a place where I was hired as a scientist, and then the economic downturn happened, and they eliminated that position, but I had to stay there to pay off my apartment lease because it was three hours away from where I had originally lived. So, I was working there as a steel bundler for quite a while. So, here's the thing. They had these overhead cranes, and you had to move these steel bars from one location in the warehouse to the other. And there would really be 2 of these coming down from the top. And, occasionally as you're moving it, those bars would swing back and forth like this. Now, if you're moving those bars, you don't want to make that swing any worse. Otherwise, they could fall out and kill somebody. Because these are like 100 feet above your head when you're moving them. So the question I have for you guys then is simply this. If these bars are swinging back and forth like this, at what point in this oscillation is the best place to start moving in this direction in order to cancel out some of that swing? So you've got 4 options. Either right here, when it's on the downswing right here, heading in this direction, when it's all the way up here, or when it's heading back in the opposite direction you want to go. At what point do you want this whole thing to start moving in that direction so that you cancel out some of that swing? Yes?
I guess it would be like in between the 3rd and 4th one, like right as it starts swinging in the opposite direction.
As it starts, like over here?
Yeah.
Okay. Other guesses? Ender?
In the middle going
In the middle going this way, okay. Other guesses?
I think it's at the far side, right? Because
Over here?
Yeah.
Okay.
And I might be being dumb. I wasn't here for the last class.
That's okay.
That's okay.
Should we just get somebody to answer with the last?
You're going to go with the upswing?
Katie,
Which spot is that? Right here?
On the way up.
On the way up, so like right here when it's on its way this way? Okay. So, there are those 4 options, and let's just get a quick show of hands. I want to see where everybody's at. How many, so again, as these bars are swinging, you want to cancel out some of that swing so they don't fall off and hurt somebody. So, how many people vote for this being the correct position to start your motion?
I think I'm going back on my answer.
Hey,
Confident.
you might be the only one that's right.
This position.
You might be the only one that's right.
Yeah, but I'd like to conform.
This position.
Which one? I said like in between.
This position.
I said like.
Okay.
I go back to my original.
So we're just going to go ahead and test this. I don't think you're going to be able to see this on the screen too much, but I'm just going to get it going. And first one we'll test, let's test the backswing where it's way back here. Okay, so I'll start moving when it gets to that point.
Oh.
So that really didn't do much, did it? No. So that one wouldn't have had any effect. Let's try when it's back up here.
Try again.
Not really. You noticed it did anything. So that one also did nothing. So this is not the correct answer. This is not the correct answer. So the downswing is the key here. And if you get this wrong, it could mean life or death. If you're working in a steel bundling factory in a warehouse. So let's see what happens. Let's do, which one should we do first? When it's going like this or when it's going like that?
First.
The first one first?
Yeah, that makes sense then.
Okay, let's try it.
Hey. Nothing.
No, that was a good one.
No, it's good.
It did slow it down. Let's see what happens if we do the other way.
Look, you're really aggressive.
So now I'm going to go when it's at the downswing going this way.
Oh, yeah, 'cause, yeah. That makes sense, because it's like the force is going against
That's how they
it.
die.
That's what I was thinking with, like,
I just made
the
everyone
side,
die.
like, didn't work in my life.
So these are our
Okay. So yeah, you do want to go at the instant this reaches the downswing here, because then you'll at least be canceling out some of that motion. As you move this way, that's going to cancel out the swing, because the swing is moving in the same direction that you are. The worst thing is when it's coming back down the opposite way. So yeah, thought that was kind of interesting for this chapter.
That makes sense.
Okay, let's get it.
I did.
What's that?
It's scholarship. 'Cause she
Two people got it right in this class.
That's the
So Jaden actually got it right in comparative origins. We had some extra time, so I asked them the same question, and he was the one that got it correct in that class. So I think AP Physics is rubbing off on him.
Not rubbing off on us.
It's okay. No, you guys are doing good, especially after that last test. That was really cool. Okay, label your notes. Energy in simple harmonic motion. Energy in simple harmonic motion. At least 3, but use as many as you like.
Energy in
Simple harmonic motion.
motion.
In simple motion.
harmonic.
Yes.
Energy is a simple harmonic
So like this?
motion.
Yes.
Okay.
Electribility queen over here.
Okay. So in terms of energy, when objects are oscillating back and forth on a spring-type system, energy changes, obviously. You've got kinetic energy when it's moving, and you've got spring potential energy when it's compressing or stretching that spring. So right now I want to make sure that we can all see how those energies change as time goes on. What I'd like you to do here is just do your best to draw this.
It's DNA.
Yeah.
Steel or diaby peroxide and nucleic acids. Yes, you're right. You know, freshman biology, that's what that's.
If you're going to use the same color for these, just make one of the lines dashed and one of them solid.
Why do that when you're coach and use? Why do that when you make dollars that Why do that when you make folded?
Did you guys already say talent lines?
You say italic, right?
Y'all speaking in italics or something.
It's like that one that's Winnie the Pooh. What is happening? I don't know what
Sound effects make everything better.
that was like visually,
I did
visually
it down
appealing
and
to the ears was a thing.
But I also
That'd be
did it in pitch with
visually appealing to the ears.
Hold up, I got you guys.
I need more sleep. Yes, you do. That's what I did yesterday. Sleep?
No.
I did! I slept a lot and it still wasn't enough.
I thought you counted your time.
No, that was days ago. Yeah. Oh,
Way back.
shit. Okay, for a graduation gift, I'm just gonna get you a bottle of baking powder. I'm gonna do it. I would love you.
Why is there negative?
I mean,
I
I
will
already
ask
love you, but like,
Well, I have to buy your love.
no.
No, I'm
Love
just
you even
having
more.
fun.
Just anytime that you're sad in this class, I'm just gonna turn around and hand you some baby powder.
If you're just carrying around a baby.
Just like in a little bag. Someone sees it, they send me down to the office.
Kylie.
It's like, no, wait, it's baby powder. It's to make someone happy. They'll be like, you're definitely on some
Bring
drugs.
in your I corroborate your story. We're just trying not to have babies.
Does it go up to E or what?
Here's
What's that
class,
E right there?
class
Does it go up there?
We all get basic.
The vertical axis is energy.
Throw it in the air.
The horizontal axis is your distance from the equilibrium point.
Some for a person
I
listening to
was
this
thinking
recording,
when we're looking for the max
it's
and
gonna be just very confusing.
So let's take a look at this then. Here's what this means. Vertical axis is energy. Horizontal axis is your distance from the equilibrium point. So these red and blue dotted lines show how the energy changes as time goes on and something is oscillating back and forth. One of these lines represents kinetic energy. One of them represents spring potential energy. Can you figure out which one is which?
SPE is the blue one. Is there not a blue one?
There is a blue.
My brain hurts.
Sarah says spring potential is blue. The other one would be kinetic.
Well, I'm just gonna say the opposite of her because that's one way to go.
Okay.
And I'm a follower.
A blue potential.
All right, blue spring potential,
I don't even
perhaps.
know which one I agreed to with it.
So let's see here.
Oh, yeah. I agree with that.
At what point is your kinetic energy going to be greatest?
When your potential is lowest.
Which is where?
At 0.
Oh,
At the 0 point, yeah. So,
Did I do it right in my head? I did
What
that
did
in
you
my.
say?
I did
No,
that
just
in my.
make
I
my
don't
head
remember.
something.
I did that
I
in
said
my
blue
head.
potential.
yep, and that's absolutely right.
Is that what
Because if you think about it,
Okay, cool.
kinetic energy is greatest at the 0 points, so that would be right here, and that would be red. And that would be right here, and that's red. Your spring potential is going to be smallest at the 0 points because at that point the object is right at the 0. So that would be here, that would be here, and you can see blue is the smallest at those locations. And obviously when it's stretched the greatest distance, the opposite is true. You've got all sorts of spring potential energy because it's either stretched or compressed, and you've got very little kinetic energy because when you're at the maximum, it's not going to be moving anymore. Over this whole thing, energy remains constant. So something you could add to your beautiful diagram.
It's a straight line.
Yes, it is.
It's a different color.
No, wait, energy is always the same number.
Energy total is the same over the entire interval. When you add them all
And
together,
it's at the highest point, right?
yes, it is at the highest point.
And
Of the crest.
Detox.
Well, you mean regular potential energy? Yeah, yeah. Non-spring potential energy is nothing for this. Yep.
Yeah, are you kidding?
Because it's at rest on the ground. So that's where it's doing its motion.
Okay, you know what time
So with a height of 0, you've got a potential energy of 0. Okay. Here's the next thing you can write down.
Nice.
And write all this down.
I liked that we both just go, cause yeah. That was the best joke I heard today.
Hey, yo, who else watched WandaVision?
Yeah.
Oh,
Equations.
is that Monday?
I think that's a good joke. That should be the one for that should be opening class. Hold on. I should open class.
This is amazing. Then you're good. Then it doesn't matter. Yeah, it doesn't matter.
Thanks. What time of year is there the most?
You guys know
spring
Ben Field is
potential
the
energy?
energy?
There is no way
Daylight
Ben will
saving?
feel it. I'm just.
Ben got a 63.
Wait, what?
I know
I
what Ben
genuinely
got,
don't
so.
know what that is.
It's Saturday.
Oh no, how about on phone?
You really should
Yeah.
I did
Wait, but you spring ahead so you lose an hour, so no, that doesn't work.
I forgot that existed.
What are we talking about?
The answer is supposed to be winter.
Read the first one.
I don't know.
I gotta know like
Sarah's having a good time.
What was the dumbest? Hi, Chris.
Who's our president?
That was one of the questions.
Yeah.
Who are the options?
Dude, my face hurts. So stupid.
I honestly didn't read it.
Why are we
I thought we were
here?
gonna say 5 seconds and next question. I wasn't gonna see what you had on this. I had to look over the answers I got.
It's not. It's such a bad
What
joke.
are some of the dumbest questions?
Yeah, but I am a bad joke, so I appreciate bad jokes.
Daylight saving.
I think
I forgot that that existed
I
until
think
you
I
said
picked
it.
Revolutionary for that one.
It was
What's it called?
option, man.
I think I still picked Revolutionary War.
I thought I was really confused. I thought that she took it down from the hallway and just kept it in her bag.
Yeah, I got 8 for it.
I mean, that's the obvious next question.
It's cold.
Okay.
Is it official that only 3 people got 100?
What day is Independence Day?
So let's talk about this briefly here. So you need to know that your overall total energy in a spring system is going to be 1/2 times the spring constant K times the amplitude squared, and that amplitude is going to be in meters. This here would be your velocity at any point. In terms of your kinetic energy is 1/2 mv squared. Hopefully that sounds a little bit familiar. When your position is equal to 0, when you're at your equilibrium point, all of your energy is kinetic. Therefore, your total energy would be equal to your kinetic energy. Same thing is true for the bottom here. Your spring potential is 1/2 kx squared when x equals, no, this would be when x does not equal 0. Then your spring potential energy would be equal to 1/2 ka squared. This should say when your velocity is 0. There we go. Because when your velocity is 0, you are at rest and the spring is fully compressed or fully stretched.
I was like, how does that make any sense?
Yeah.
What?
Okay.
Never mind.
Never
mind.
Also.
Is it when velocity is
Nope.
0 and
X equals 0.
you would have laughed, I promise. What did you say? I probably will still laugh because it doesn't work now.
Questions on that? Okay. So those are special cases.
What did you say?
So the question comes in, what happens if we don't have a special case? What if x does not equal 0? And what if velocity does not equal 0? Then what do we do? Well, yes. Under these conditions, and you can start writing this down, total energy is going to be equal to both kinetic and potential. When you add them together, that is what will give you your total energy, as opposed to the scenarios I just pointed out, where all of your energy is kinetic, or all of your energy is spring potential. So let's just see what happens if we throw actual equations into this thing here. So total energy was defined as 1/2 Ka squared. Kinetic energy is 1/2 mv squared.
Yes.
And spring potential, 1/2 kx squared.
So we didn't say rid of the 1/2 or like the.
Yeah, first thing I'm going to do is toss out all the 1/2s.
I don't know, but I think it's funny that I only remember equations based off their sounds. What happened? Wait, what's etot? Oh, you mean 1/2? Cots.
Cos squared equals mv.
1/2.
What? Let's forget about that one.
My bad.
I didn't even realize he said
Well, I just don't get it.
We are children.
I don't think the viewers at home heard it, so let's.
I think they
children of Jesus.
I didn't mean it.
Okay.
I just don't understand what's so funny.
Pat's face just made it.
The second Ben started laughing, I was like, oh boy.
Oh my
And
god!
then just we just tried to say so serious. And it just
Anyway.
We can erase that clip, right?
Oh yeah. This is one and done here. I do no editing whatsoever in these videos. So, okay.
Alright, let's go.
If typically, all right, guys, listen up. Here we go. Typically for this, we'd want to solve for velocity. So let's isolate the velocity and just see what happens here. So if I want to move kx squared to the other side, I'd have to subtract it. That would be equal to mv squared. Definitely done sounding these out. So if I want to get the velocity by itself, I'd divide both sides by m. I'm also going to pull out this k here. Yes?
That's my question.
Yeah.
Are they the same K or different K?
Same k.
Same K.
Square root it. Just square root it. Just square root it.
Yep. So another thing I'm going to do before I square root it is I'm just going to separate the k and the m from this here because it looks a little bit prettier. So that's what we would end up with. Does this look a little familiar?
That is velocity equation.
And we wrote it over there.
So when you see these equations that I give you, you should know that they don't just come out of nowhere. They can be found simply by doing some physics and deriving them. And this is no different. So when you're calculating your velocity from this equation, it is based solely in your energy equations right here, and you just pull out the V. Let's do an example.
Can we prove an equation that he already told us? I just feel cheated. I'm not going to. Oh wait, no, I signed up for stats.
Only 5 stats.
Let's do red. Yeah.
Let's do red.
Yeah. I'm not happy about doing it.
I'm ready for red. You guys believe this is the second to last session of notes you're going to have in this class?
I'm gonna cry.
I know, right?
It's weird because we're going on spring break, so because
I'm not gonna remember
most of my
any of
classes are
this.
finishing this week because I have APs, it feels weird. Like, I feel like it's the end of the school year.
Mm. It does feel strange, for sure.
I'm just confused.
It's okay, I haven't been able to take any of my tests, so it's not over for me yet.
And just to let you know, it is getting warm out, so that means it's about time to go back to normal for me.
But I like it.
That's so nice.
I know, but it's...
I like the facial hair better than the no facial hair for you.
Oh, well, I appreciate that. How many people prefer the facial hair? Raise your hand. Wow, seriously?
Yes, sir.
Man, I must have some ugly face skin.
No! You look like both ways. This is better.
No, I appreciate that. Thank you.
It doesn't mean
I know. I'm just giving you a hard time.
We're not picking between good and bad. We're picking between
Good and better.
Right. So here's...
I mean, came out with a beard last year. He came back from that one winter break, and all of a sudden,
I don't know if Kylie heard me, but we started the class. You took off your mask, and I was like, "This might be weird, but your facial hair looks good today."
oh yeah, I was baby faced.
I didn't hear that.
You didn't hear? I didn't think you did.
Nice.
How quiet did you say? I was right next to you. It was really quiet.
It came down to here. If I pulled it, it just came down here.
Anywho.
Alright.
I grow a beard.
You grow a beard?
No.
I don't think you can.
Imagine Ben with a beard. I don't know. Sorry, I overheard that.
Well, you will be able to grow over time. It's the sort of thing where as you get older, it just gets fuller and fuller.
Idiot.
What
I'm
now?
gonna crush Mr. Student Body.
How did you take that, Katie?
This is what happens when we.
I'm dying to...
You can grow it over time, so I turned to Kylie and I go, "Here we go."
You never know what's going to eventually
She
be
said
in
we
style.
could over time, so we're gonna do it.
Katie's growing a beard?
Yeah, no, me too. Katie.
You guys remember this beard?
Oh yeah,
Nice.
I liked yours too.
Came down to here.
You know what you should have done? You should have woven it together before you got rid of it.
I'm just really dumb.
Like,
Okay.
have you seen like
Katie, hold on.
Well, they're all
Katie.
braces.
My uncle has it right now.
All right.
There's a guy who works out at the gym who puts his beard in ponytails.
What?
Back to it, guys. Here we go.
Yes.
He's got a bunch of different.
Oh, like
He's got a bunch of different ponytails. It's awesome.
So, if these are the values that we know, and I want to calculate the total energy of this system, what am I going to put in for amplitude?
Yeah.
Incorrect.
0.03.
Oh,
It's going to be 0.03, absolutely.
Let's go.
Because we got to get this to meters. And centimeters to meters, it's going to be 0.03 meters. And that's going to give us a value in scientific notation.
I can't. Oh, do you need this
Do you mean e to the negative third?
Yes, thank you. Absolutely, that needs to go there.
E to the
That would
negative
make
third.
sense.
Possible?
What?
It's e to the negative third.
Yes. No, capital E to the negative third.
Yeah, what is this?
So let's say we want to figure out what the total maximum velocity is with this. If we want to figure out the maximum velocity, somebody tell me a strategy.
It's the value from because sine of anything is 1.
Energy.
By the way,
Which kind of energy?
kinetic is.
Velocity energy.
Velocity energy, yes. AKA kinetic energy.
what am I talking about sine for?
So your total energy
Science.
will, if you set your total energy equal to kinetic, this means at the point at which your kinetic energy is the greatest, if all your energy is kinetic, then you can set that number equal to kinetic, solve for velocity, and you're good to go. So let's just do that. I'm going to use variables this whole time, so I don't have to keep writing that big number in scientific notation. Thank you, Sarah. Nothing gets by you, does it? So if I want to solve for velocity, then I'm just going to isolate the v. Put it in solitary. Let's see. So that's equal to v squared. So to get rid of the square, we erase it. And then we got to take the square root of the other side.
What is going on?
You know, I had an experience with that song yesterday.
What song?
Because I like that song. That's by Hadaway, right? What is love? So, yeah, right? It's like you can't not like that song. And I heard it start to play on the radio, and I was like, yeah, man. And then it was like one of those things where the radio is advertising itself and all the good songs they're playing. So after like 3 seconds, it was a commercial. I was so disappointed.
Aw, sadness.
Right?
My favorite is when radio stations like, yeah, we're in the middle of another hour or another hour of no commercials. And then as they talk for like 4 minutes, they're just like, yeah, we played music for an hour straight, blah blah blah, and then they go on. By the way, this. Mm-hmm. Can't do it.
It's not a commercial. It's talk show.
It's adjustable. Okay.
Look at the backside.
Questions thus far?
No. Remember back to what I said at me, guys, like visually appealing to the ears was a thing.
Mm-hmm.
The way you said that
These
was.
days are us. They're just like.
Well, good. I appreciate it.
What's happening with us?
What's the equivalent of visually appealing to the ears? What would that be?
Katie, you inspire me.
Sound.
ASMR.
Music to my ears.
Music to my yeah.
Oh!
I don't know how I didn't think of that.
ASMR.
What's... I missed an entire
ASMR.
conversation again. I know, I keep zoning in and out. You guys intrigue me. They intrigue me. There's not too much sound from over there.
It's always this group and then that group.
Hey, Butter. Hey, Ender.
Okay.
Just like,
Final scenario we're going to go through today. Now, our distance is 1 centimeter. So this is not the amplitude, but once again, we want to figure out the velocity when the object is 1 centimeter away from the equilibrium point.
we have to put it in meters, right?
Exactly.
Now you're finding
No, we're still solving for velocity here. Amplitude was given as 3. Right. So now instead of finding the velocity at the 0 point where it's maximum, now we're finding the velocity when it's 1 centimeter away from the equilibrium point. So at that point it will have slowed down a little bit.
Okay. Make me very happy. So bad.
What is happening? What is up? Sorry, I heard.
What is up? Baby, don't hurt me.
You know, it's funny. Even though when we're done with this section, I'm not going to be presenting any new material after this, even though that takes a lot less preparation for me, then I'm going to miss giving you guys these lectures. This is so much fun.
Aren't you so glad you recorded this year?
Yes, I am.
Just swear. Remember to
Especially
swear.
today.
Thank you, sir.
And Servers.
You know, I think for the last day, Sarah, maybe you should just be the one to come on.
No. It's just you kept turning around, and normally when you turn around, you're done with being famous. So then it just scares me because I don't.
Right. I got you. Yeah.
It scares me because it's not right. Yeah, sure, he has the entire textbook copied down word for word.
That's good, though, because then
Instant replay.
that way it's like, at least I don't get too far before I forget stuff. So I appreciate that you do that. Okay. So when we do all this math, which I will do.
What? Stop laughing at me.
Hey, look. Hey, why are these all normal and then one of them's, why is your eyes sparkle? You would take out and hand it to someone. I have. You have actually. Who have you handed it to? Oh. Have you seen his eyes?
Can I borrow this from you for someone?
Your eyes sparkle?
So, as we would have expected, we get a velocity that is a little bit less than the maximum velocity from the previous part of this question. It's just a little bit less because we're not too far from that 0 point where the velocity is at its maximum value, but it is, you can tell it's a little bit smaller.
You have influence. I like how the last words are all in caps. You are valuable.
And the last step of this whole thing, we're just going to calculate some straight up energies here. Very straightforward.
Straight up and straightforward.
That's right.
Oh, we need more room.
Yeah, probably.
That last example, so I stayed on the same page.
You can probably write it on the side if you do a little box around it.
Yeah,
So
this
it's
is, it's not going to take up much space.
It's stuck in my head now. This is not good.
Do you know more than just that?
I know
That's
the
legitimately pretty much the whole song. Because they just repeat the first part. Actually, no, there's a little bit more. But
I know the SNL skit from a while ago. That's all what I know about it.
You're locking in. Someone just squeezes ahead and you feel like inside their joints.
Excuse me, what?
You squeeze his hand. I find it quick like a pen.
Oh yeah.
Oh,
Yes.
And I was squeezing his hand. His hand quick.
Yes.
It's weird.
Jaden is a robot, confirmed.
Oh, my hand does that.
You said you wouldn't tell anybody.
Sorry, I couldn't help it.
These juniors. Oh boy. Let
You
it
should make a
go.
choir out of all
Let
these
it go. can't hold him back anymore.
Our darkness past.
Christ hath assumed his reigning power. Behold.
Guys, what song should Mr. Halfway, can you get us in the choir concert, please? This class.
Get you a choir concert?
Yeah, we're gonna make a choir class.
Yeah, that sounds like fun.
Just say like the refrain.
What song do we say?
Wait, we need to do tequila first. The
Go
original.
back to music.
I think.
Latina.
No, we can sing that song.
Oh my gosh.
Placido can make noises and Ben can sit in the front.
Remember when I said that it was my most listened to song? And that's that was Sarah's most listened to song, wasn't it?
There we go.
It's so
We're back to
Michael Phelps. I should really go and put it in the camera.
That's right.